thanks everyone for coming. We're gonna get started. Thank you all for coming to my workshop on CI/CD exploitation. It's going to be 2 hours, so it's gonna be long. I hope I don't bore you to death. There's going to be a lot of demos. Some of the stuff gets pretty complex, so let me know if you have any questions at any point. Just cut me, raise your hand or something. I'll be watching. Because if you get lost, then it's gonna be tough to recover after that. So go ahead and just raise your hand and tell me you have a question. So brief about me. I'm Ignacio Dominguez. I go by Congonator online. I'm a cloud security engineer at Circle, which is a crypto company. I'm a Circle, yes. Okay, let's talk after. Nice, nice. Yeah, so I work at Circle. I also co-founded a company called Hackers Training with this man over here. We do cybersecurity training online and also in conferences for cloud stuff. So like AWS, GCP, and Azure. So yeah, if you're interested in any courses online or in person, we will be giving some vouchers at the end for discounts and all of that. So on today's agenda, we have a brief introduction into CI/CD to just get everyone to the level that they understand what CI/CD is. A really quick couple of slides. Then we will be looking at poison pipeline execution, which is a kind of attack in CI/CD. Then some attacks, both from cloud, so from CI/CD to cloud and from cloud to CI/CD, which is a perspective that I don't see anyone talking about, going from cloud to CI/CD instead of CI/CD to cloud. Like going backwards to then maybe reaching other accounts or other stuff. Can be really interesting. Number 4, we're going to talk about the GitOps paradigm, what it is and why it's useful, what are the implications it has, dangers, a lot of dangers. On number 5, we're going to be focusing specifically on GitHub Actions, or specifically on self-hosted runners, which is when you run your own servers to run GitHub Actions. There are some things that can happen when you do that kind of configuration. So we'll look at some examples of things I've seen in the wild that can compromise an entire company. And finally, if we have time, brief mention to supply chain, just because there's been recently some big supply chain attacks on GitHub Actions that are worth mentioning. And as I said, all of them are going to have a lot of demos. There's 9 demos, possibly 10. We'll probably have to skip some in the interest of time. But yeah, I hope you enjoy. So let's get started with some basic knowledge about CI/CD. So CI/CD stands for continuous integration and continuous deployment, or delivery, depend on who you ask. To me, both are valid, mean slightly different things, which we'll see later. And it's basically a system to automate the building, testing, and deployment of code. So from I have a ticket in Jira to my new feature is deployed, automating that whole process is what I would define as CI/CD. And some common tools are GitHub Actions, which is the one that we're going to focus today because it's really easy to use, or Jenkins, GitLab CI, Circle CI, Drone CI. There's tons more. Okay, continuous integration. So this one is, there is a cohesive definition. Everyone says it's integration. There's no 2 options. So this one is about building and testing code before it gets deployed. So whenever you push your code to your repository, something automatically builds it, tests it, says everything's is okay, and then it will go back into the CD part. So what this helps with is catching bugs early. That means with the automated testing, we can do both like end-to-end tests or integration tests, unit tests, all kinds of tests, just to make sure that our code works correctly and we're not introducing old bugs or new bugs. We can also ensure that code quality is up to standard of the company. Like maybe you have a specific linting that you want to do on every single file, or one example I've seen a lot is when they don't want complex functions. So they have a tool that studies the complexity of your code. And if there's a function that is too complex, it will tell you, okay, you need to split this into several functions to make it easier to read. And finally, for security scanning, so that would be like SAST scanning and SCA scanning to just check that you don't have vulnerabilities. In the CD part is where I say there's a bit of more debate if it's deployment or delivery. For me, when it says deployment, it's about deploying code. So sending your code that is already built into a production environment. Well, it could be a Kubernetes cluster, it could be a EC2 machine like a VM, it could be anything. Just delivering it where it's going to be served. And then on the other hand, delivery for me means when you build a package and you put it on a registry and then it's going to be consumed by a third party. Like maybe you're building a npm package and you put it on your registry where it's then going to be picked up by someone else. The interests of CD is reducing manual intervention. Before, people would have, like DevOps teams, would have to get with the developer team. They would plan like a 2-week sprint or maybe even a month sprint. All the features they're going to be releasing during that time. They do all the testing. They put the new release together, 2 weeks training it and testing that everything works well. And then after that, they do a big like upload to their servers. They will SSH into the servers, update the code, all of that manually. A lot of clicking around and that kind of stuff, which is very error prone. It's highly likely that they're going to mess up something up or forget to do one step in one of the times they deploy code, and something will stop working or there will be a new bug introduced. With CD, since it's all automated, you first of all reduce how many people need to access your infrastructure. The company that we run, I've never SSH'd into any of our servers in my life. When the server needs patching, I kill it and I spin up a new one instead of having to go through the process of SSHing and doing fixes and all of that, which is very error prone. It also makes it so environments are very consistent. You have test, staging, production, development environment, separate environments. It's really easy with CI/CD to make sure that the same configuration has been delivered to all of your environments without having to manually go and check. And last of all, it's for faster release cycles. So companies that I've worked in, mostly startups, they were doing between 10 and like maybe 50 deployments a day, which is insane to think. In like 20 years ago, that would be insane to think. People were doing one deployment every month or something like that. And that's all possible thanks to the automation of the whole pipeline. So this is a bit of the flow. A developer will get a ticket or something. They will decide to do a new feature. They submit their code to a Git repository. That will automatically trigger a pipeline. The pipeline will start running builds to build any binaries or container images, packages, anything that needs to be built. Then some tests. Normally tests happen after builds, because normally in order to test it, you need to build it first. So in tests, you can do unit tests, integration tests, any kind of tests, end-to-end tests also. End-to-end tests might get a bit complex, but they are possible to do in certain scenarios. Finally, if they need to deliver, if it's like an npm package or something like that, that will be the delivery phase. If they need to directly deploy, that will be the deploy phase. So yeah, delivering, you send the package to wherever you need to send it, so it gets consumed, and deployment, you update the live environment with the new version. No questions? Okay. So I've kind of already gone through why it's important, like why are people doing it? Every modern like startup or tech company is doing this kind of strategy to improve their way of working. So I won't go through this individually, but the one that I want to mention that I haven't mentioned just yet is better team collaboration. Since this is very easy to spin up different services, you can have microservices that have like different pipelines and all of that. It makes it so teams can work at different features at the same time without colliding with each other. And that's why it's common to see like over a dozen deployments a day, because people can work in parallel and get the new features to the clients as soon as possible. So today we're talking about security of CI/CD. So that was a brief introduction into CI/CD. Now let's actually start talking about security. There's two ways to look at security in CI/CD: security in the pipeline and security of the pipeline, which mean slightly different things. So security in the pipeline will be things like security scanning for the code. Yes, probably. I have no idea. If you want them, just let me know. I'll share them with you. Okay. Yeah. So security in the pipeline is mostly about like static analysis of code or software composition analysis, just trying to figure out that you have no vulnerabilities in the code that you are building or testing. That's not what we're interested in today. Today, we're testing security of the pipeline. How secure is our CI/CD infrastructure? CI/CD is used to build the cloud, so it has the keys to the cloud. If I'm able to hack CI/CD, I'm able to hack your cloud. That's as simple as it gets. Normally, there's super critical credentials in CI/CD that have access to everything in your AWS account, your GCP account, or even like other third parties like GitHub. You see CI/CD pipelines in GitHub that have crazy credentials for GitHub, so you can like privilege escalate within GitHub, stuff like that. So security of the pipeline. Here are some of the things that can go wrong, and some of the things that we need to take into account. Control mechanisms such as branch protection. This is something we'll talk more about this later, but just so you keep it in mind, it's for very interested when talking about GitOps. We'll go back to that later. We have identity and access management. So who can access my pipelines? That's interesting in there's a lot of companies I've looked at that have very open GitHub permissions, so everyone can write a PR to every single repo. Everyone has like write access, not maybe not to the main branch, but to other branches. That can be dangerous. So you need to figure out who can actually trigger pipelines and with what permissions those pipelines are running, and if they need reviews or not, that kind of thing. Poison pipeline execution. This is a technique that someone thought of a really fancy name for it. Is basically changing what the pipeline does, affecting the code that runs in the pipeline. We will talk about more about this later, but yeah. In terms of leaking secrets, CI/CD needs to build stuff, interact with other third-party like SaaS providers, stuff like that, to upload code or to download schemas. There's a bunch of stuff it needs to do. So there's a lot of secrets. If those secrets can be leaked, then it's very normally they are very sensitive, and it could lead to higher compromise of their infrastructure. So at least in my experience, what I've seen, I've tested a lot of CI/CD systems, and what I've seen is a lack of least privilege. Most people just give admin to everything, because if you're going to run something that creates AWS resources, it needs to be admin on the resources that it needs to create. So people are just giving like AWS admin to GitHub Actions. In my opinion, not the best option, but it's definitely the easiest and quickest. These startups, they need to go fast. So they're not going to stop just to do this privilege every time. And finally, supply chain attacks. This is where instead of trying to compromise your target, you compromise someone they trust, even if it's an indirect trust. So they use third-party dependencies in their pipelines. An example of this was in March. TJ Actions, that's a GitHub action that is public, got compromised by APT. Not yet. There's no theories yet onto who it was, but they were targeting Coinbase, a cryptocurrency company. The attack was really, we have an example later, but it was crazy complex and very targeted to Coinbase. Like it only did bad stuff if it was a Coinbase repository. If not, I'm just here quiet, no one can see me. And they got caught by Coinbase, and as soon as they got caught, they decided, okay, we've been seen. Let's just try to get as much credentials as possible from everyone. So they removed that check that if it was Coinbase, they would do the malicious stuff, and they were just trying to leak credentials for everyone that was using TA Actions, like 23,000 organizations or something like that. Cool. So now we're gonna get into some attacks. First thing we're gonna talk about is poison pipeline execution, which is basically when you are able to run malicious code inside the pipeline. There are two ways of doing it. This could be direct PPE, so poison pipeline execution. This is when the attacker directly is able to change the CI config, so change the steps that happen in the pipeline in the GitHub repository or whatever kind of repository it is. They'll be able to change the steps, and then the pipeline, when it executes, it runs arbitrary code. So that's the easy way. If it's not available, then you can do indirect PPE, which means that you inject malicious code into the pipeline in other means. This could be, for example, you change files that then the pipeline uses, like a make file or some Python tests or even Terraform. There's ways to do remote code execution when running Terraform. We will see those later. Uh, it's also possible, I've seen this in the past, command injection vulnerabilities using things like branch names and PR titles. Those get like, maybe you write a description and you send it with your package or something like that. If you don't configure that correctly in the pipeline, it's possible that the branch names and PR titles get injected into bash in ways that allow you to do command execution. So here is our first demo. This is going to be a really easy one, just to make sure everyone gets a grasp on what PPE is. We have our attacker. The attacker has access to a GitHub repository and can push. That GitHub repository is connected to GitHub Actions. So that means that if they change the code inside that GitHub Actions, here in the workflow files, it will be able to execute whatever they want in GitHub Actions during the pipeline. In this example, I showed that the pipeline might be like logging into AWS using a role and then deploying stuff to different like Kubernetes or ECR and code artifact. The example I did for the demo doesn't do that. What we are doing is leaking a secret. So GitHub Actions allows you to set secrets for your pipeline that might be used during the pipeline execution. So that's where people should be putting their sensitive credentials. I've seen them hard coded, I've seen them in environment variables, but they should be in secrets. And we're going to show how those secrets could be leaked. So this here, is it small? Maybe. Okay, hopefully that's big enough. So this attack scenario, this entire directory where we are is a GitHub repository, which we can see here actually, number one. This is just a GitHub repository with a README file and a workflow. This workflow currently shouldn't have anything too crazy. So as you see here, we are setting as environment variables some secrets that we have. This should be safe. Those secrets will be masked by GitHub Actions and they won't appear in logs or anything like that. And we're just doing some echoes to like simulate that we're doing something, basically. Our attack is going to consist on changing that file. And instead of just doing those echoes that were like legitimate things that the pipeline was doing, we're going to be exfiltrating the secrets by base 64 encoding them. So if you were to do just echo API key, GitHub is clever enough to say, okay, that's a secret that I have stored. I'm going to mask it. And you will see a bunch of like asterisks over it and you won't be able to see it. So now I'm just going to copy this. I only need this part up here. Yeah, at the bottom of this, I also have another way if you wanted to exfiltrate it like through a curl command or something like that. But this should be good enough. We'll go into our CI here and just paste it here. Too much. Okay, that'll do. So I'll save. I'll go ahead and commit this. So let me cd into number one. Okay, I'm in that directory now. So I'll do a quick git status. So you see we changed that file. Just go, maybe it's small too. Okay, that's a bit better. So I'll just do a git add and git commit. And we can push it. So we're pushing directly to main, which probably shouldn't do ever, but we're pushing directly to main. And now if we go to the repository here, we'll see there will be a new action running. dodgy. And in this action, if we go to the steps and we open the read secret step, we'll see here some base64 stuff. Just gonna copy this. Let's base64 decode it. And this is not an actual API key. So that was the secret that was stored in GitHub. We managed to exfiltrate it. So this is just a very simple example of a direct PPE. The next example I wanted to show.
What happens if you cannot find on the main branch, but you can write on other branch? This, as you said, is weird. You can directly
Yeah.
push.
So it depends on how the pipeline has been configured. If you see here, it says to this pipeline will only run if it's a push or a pull request to the main branch. So if you didn't have write access here to the main branch, this would still run because you would be able to open a pull request by pushing to a different branch and then opening a pull request, and then it will run. It's like that in most places. So most places expect you to open a PR, just write to a branch, open a PR. Something will happen automatically in the PR. Checks and tests will happen in CI/CD pipelines, and then someone will have to review that PR and the checks in order to say, okay, this code is good, we're approving it, and then it gets merged into main, which could trigger another pipeline. Any other questions? So you can configure both things. If it's pull request branch main, it will mean when you open a PR to main. Yeah. If you want to do it when it's merged, it will be on the push to main. Merging is pushing. It's the same. Well, it's not the same, but when you merge, you're doing a push. Okay. No more questions? Cool. So the next one was going to be a indirect one. I think we can skip this one because it's really similar, but I'll go through the diagram so you get the gist. So in this case, instead of being able to modify directly the pipeline, the steps in the pipeline, as we did before, modifying the YAML file, in this case, the attacker will be able to modify tests that run inside the repository. In this case, they're using Python, so they are running PyTest. Actually, let me show you the attack so you can have a better feeling of what it is. So the attacker would go ahead and add this to, let's check the pipeline. Here is our pipeline. What this pipeline was doing, it was installing the dependencies of whatever service this is written in Python, and then it's going to run some tests down here using PyTest. So if the attacker was not able to modify this document here, this file with the instructions, they could still modify the tests, which are in this folder here. And if they were to write a malicious test like this one, which reads environment variables that contain the secrets and then sends them through a post request to the attacker, that will be a indirect PPE. Just in the interest of time, let's skip this one and go to more interesting ones. Any question about indirect PPE? Okay. Cool, Terraform. Anyone knows what Terraform is? More or less? Okay. Yeah, so Terraform is something developed to do infrastructure as code. It allows you to write a declarative way of writing what infrastructure you want to deploy. It's cloud agnostic, meaning that it works on all major cloud providers. It also does non-cloud providers like SaaS applications. For example, GitHub has a Terraform provider that you can use to create GitHub repos automatically, or Datadog has a Terraform provider to create different log categories and stuff like that. So Terraform has been like the best standard or most adopted standard for infrastructure as code. There's now an open source version of it because they went kind of private last year, and it's called OpenTofu. People are still using Terraform from what I can see. It doesn't seem like people have been migrating to OpenTofu. So main advantages of using Terraform is that it's version control. Since you're storing your code in a GitHub repository, really easy to do version control of your infrastructure. Something breaks, just revert back to the previous version. It's also peer-reviewed. You can use CI/CD pipelines and like GitHub branch protections to do peer reviews. Make sure that one person by themselves are not able to change infrastructure. Someone else needs to check it, which is really good. It allows you to create reusable modules. So Terraform modules allow you to have like input variables and then output variables. And that way what happens in the module is like abstracted from the final user. And for example, you want to create a Kubernetes cluster. You get a module to create Kubernetes clusters and you give it, okay, I want 5 nodes and I want these other tools to be installed in the cluster. And then the module takes care of all of that without you having to actually write all the Terraform. And that way it's reusable and you can like collect it from the internet, use it in different companies and all of that. It has state management, which means that Terraform is always aware of what's going on in your cloud, in the Terraform state, and in the code. So it's able to do a correlation of the three and detect drift. If your cloud, someone has gone into the portal and has been clicking buttons, which you shouldn't do, and now the state doesn't match what is in the cloud, Terraform will automatically correct it the next time it runs. So it has drift detection and deviation correction. And finally, it's very easy to integrate with CI/CD systems like GitHub Actions or whatever. There's one called Atlantis, which a lot of companies use. It's really fun to hack into because it normally has AWS admin credentials for everything. So there's normally juicy targets. Okay, so this is the normal Terraform flow. When a developer wants to add new infrastructure, they will go ahead and create a Terraform file. Maybe it's easy for me to point with. Yeah. It will create a Terraform file, push it to a repository that triggers when they open a PR, that will trigger a pipeline in GitHub Actions. In this example, it could be another provider. That will assume a role in your cloud infrastructure, do a plan, because in Terraform, you first plan, you review the plan, and then you apply. So once you have the plan going on, the plan will be like added to a comment in the PR so someone can review it. Once developer 2 is happy with it and has reviewed it, he will click approve. The PR will be now able to merge into main. And once it gets merged, it will be applied automatically by Terraform Actions into your cloud environment, changing whatever has changed. So that would be like the legitimate way. Then if there was an attacker, the attacker could change. This is an attacker, and we assume that the attacker has write access into the repository to a PR. So not to the main branch, but they are able to open a PR. In this case, what's going on is they add a malicious resource into the Terraform code. That makes it so when the PR triggers, it triggers the GitHub Actions, assumes the role. That role is in GitHub, in the Terraform, is used by Terraform. So Terraform has access to the role. You can send those credentials back to the attacker, and then the attacker has access to the infrastructure directly. So it's able to compromise the credentials that Terraform is using inside GitHub Actions, send them back to the attacker, and that way the attacker can access the infrastructure. So notice that this is during plan time. So no peer review has been required just yet, and you have already been able to steal credentials. So let's do a quick demo on that. Any questions? No? Okay. So I have here my third demo. We have a Terraform repository. It has a GitHub Actions here. This GitHub action is doing a plan, Terraform plan. So this triggers when there is a push to any branch. And it will do first a plan. Here, Terraform plan. In order to do a plan, first it has to do a Terraform init. Well, here we're configuring credentials for AWS. We will talk a bit more about how to configure credentials for AWS in GitHub Actions and some dangers that there are in the next demo. But for this one, we're just configuring them. Then we're doing a Terraform init, which is needed just to initialize all the providers that Terraform is going to use. Make sure that Terraform has all the code it needs to execute, and then we're going to do a plan. Up to this point, nothing should change in your infrastructure. Technically, you don't even need like administrator access to the infrastructure. Just with read access would be enough, because just the plan just reads the Terraform code, reads the Terraform state, reads the cloud, make sure all of them are the same, and ensures that whatever you added to the chain to the Terraform file can be added to your cloud, and that's it. It gets a pretty plan saying, okay, I'm going to add 2 virtual machines and a bucket, and that gets sent back to the GitHub pull request. And then here, if you were to merge this pull request back to main, it would do the Terraform apply. But in order to do the Terraform apply, you would need to do the merge, and in order to merge, someone else would have to review the PR. I didn't. There's a limitation in GitHub where if you have a private repository and you're not paying for GitHub like theme, which is one of their plans, you're not able to use GitHub branches. So GitHub branch protection, sorry. So we have to imagine that you couldn't. You could totally hit on merge and it would apply it, but for the sake of a realistic demo, we just assume that you cannot merge into main. There's a GitHub branch protection. So the idea of the attack is we're going to use a data resource right here. This is a Terraform resource of the type data. So it just collects data and stores it into state. It's an external one. So when you do the external provider for data resources, you can execute a command wherever this is running. This will be running in GitHub Actions. We have the ability to run commands in GitHub Actions. So what we're going to do is run a command that runs a curl with a post request to the attacker. And the data of the curl is going to be base64 string of the environment variable that contain the word AWS. So that will get all the credentials for AWS, base64 encode them, and send them to an attacker. So let me start an ngrok listener and a catcher. Let's get the URL and update it here. Okay, now I'm going to copy this, paste it into our Terraform. This is the legit Terraform code that was in this repository. So it was just creating like an S3 bucket with a random name. And now I paste my malicious resource, save it. Let's do into number 3. Okay, it's status. So you see that, well, we've modified the README just for copy pasting, but yeah, the main change is in main.tf. Now commit this. We'll first add it. Git commit dodgy. I'm pushing it to main directly. I need to switch branch. Git switch. Let's do dodgy. Okay, I'm in the dodgy branch and I have one commit, so I should be able to do a git push -u origin dodgy. That should push this to a different branch. And now if I go back to the repository here, is everyone following? Nice. Okay, so I'll just visit the repo here and we should see a big button that says, okay, there's a new commit to a different branch. You want to do a pull request. So let's do a pull request. Doing a pull request from dodgy to main. That looks good. Create the pull request. And this should start the job. So in this job, we should see if you see the Terraform apply one, that didn't run because it didn't meet the criteria. This is not a merge. This is running in a plan. And now if I go here, it's working. It's doing a Terraform init, and now it's doing the plan. So once the plan starts, it's doing my malicious. Maybe I need to make it slightly bigger. It's making the malicious data external resource. Still reading, and here we have the big long base 64 data that maybe it's not even worth for me to copy paste. Okay, it looks more or less good. Let's base 64 decode that. I think it has new lines and that's going to fuck everything up. Oh yeah, it does have new lines. Let me get rid of the new lines. Okay, so here we have the AWS related environment variables that were in that GitHub Actions. And if we would go ahead and export those, okay, I'll use this one. I'm just going to copy paste those credentials into this little template I have to export them. Thank you. Okay, so this is the last one, which is the token all the way to here. Okay, and that should be good. So I exported those and everything exploded. Oh no. I updated my system a couple days ago and now I have an incompatibility with my AWS CLI. That might break some of the other labs. Uh, we'll get there when we get there. Okay. So yeah, essentially this would show us that we are now logged into AWS as a certain user. That user in this case was AWS admin. But yeah, my AWS CLI is not working. So that's great. Demo gods are not happy. Okay, let's move on to the next demo. Any questions on this? PPE using Terraform? And now I don't have internet? Question.
So you said that you provide access over the repository, right? To the permissions.
Yeah,
But you have actually performed a pull request. If the repository was public, anyone can open a pull request. So
depends on how they have it set up. You will need to do a fork of the repository and then a pull request. And there is certain settings in GitHub that allow you to say, okay, if the pull request comes from a forked repository, and someone that is a contributor to this repository needs to approve it before it runs any GitHub actions. That's the way that you can protect against this in public repositories. Probably shouldn't have many public repositories that hold Terraform code, but yeah, that's probably not the best idea. No other questions? Let's continue then. How am I doing on time? Oh, not too bad. We almost at 1 hour. Kind of bad. Okay, so yeah, I prepared more than enough just in case. I didn't want to run out of stuff to say. So I prepared a lot of stuff and then maybe we need to cut some corners. So CI/CD to cloud and cloud to CI/CD. What we just saw with Terraform, that's a way to go from CI/CD to cloud because we're stealing credentials from the cloud. We're going to look at that again, specifically a misconfiguration that we found in some clients in the past that allows any GitHub actions from any repository in GitHub. So anyone essentially that can create a GitHub repository to assume a role in your AWS account. Normally, these roles are really privileged because they used to build the cloud. So the ones that we found where like everyone in GitHub can assume AWS admin in your account, which is like a super critical finding. So the way this works is there's basically two ways to assume to access AWS from GitHub Actions. First one is not recommended, which is using IAM users. IAM users have long-lasting credentials called access keys. You can just stick those access keys into your pipeline and use AWS commands in order to interact with AWS. As I said, long lived, not recommended. Once they're compromised, and if you don't realize and don't delete them, they're valid forever. The other way of doing it is through IAM roles using OIDC. So this is short-lived credentials. You configure OIDC in your AWS account to trust your repository. You're able to specify using IAM conditions that the audience of the token that gets passed to AWS is going to be STS Amazon AWS.com. That's the security token service from AWS. So the service that is in charge of exchanging credentials and that kind of thing. And then in the subject, that's the interesting one, the subject claim, you can configure the repository that is allowed to do this. So this is what would stop the attack I was talking about. If you are to specify repo colon your organization, your repo, and then you can even specify like specific branches. So only the main branch can access this role, or even like you can go further and put environments, which is a GitHub action abstraction. So in that case, you're able to very specifically scope this trust that you're placing in GitHub Actions to only be able to work from specific repositories. So this is the misconfiguration. When people do something like this and they add a condition where the repo can be anything, or they just simply don't even add a condition about the subject. That means everyone in GitHub Actions can access this role. You can see here in the principle, this will all be the same for GitHub Actions, token actions GitHub user consent.com. That's the you need to create it in your AWS account, but it's the provider that GitHub will use. So yep, that's the misconfiguration. And I was going to do the demo, but knowing that my AWS CLI is not working, it might not even be worth doing that demo. Let me briefly walk you through it. So let me show you the actual IAM role that I have for this. I think it's here. Yes, this is the IAM role I had prepared for this demo. And as you can see, it has the condition that the subject is repo anything. So just by knowing the ARN, which is an identifier in AWS, the identifier of this role, I would be able to go ahead and here I have the example. This one? Yes. Yes. So here I'm specifying, I'm using the configure AWS credentials action, which just means I'm reusing code from other people to assume a role in AWS. And I'm specifying the role that I'm trying to assume, this one here. And then I was running, this we can actually do this one because it's going to run the AWS CLI from GitHub Actions. GitHub Actions does have AWS CLI working, not like me. So let's quickly do this one. I'll go here. I think I already had it configured. Okay. That looks good. So now this GitHub Actions is configured to assume that role. Let's commit this. Okay, so pushing that commit, and now we go to that repository. We should see that we were able to assume the role from that repository, even though we didn't specify that repository. GitHub Actions. So if I go to Actions, there should be a doji Action. Oh, the speed. Any questions in the meantime? No? I'm tempted to hit refresh, but then it might start all over again. Is it getting slower? I think the page broke. Yeah, this is broken. Oh, and now maybe I lost internet.
Yeah, yeah.
Demo gods are not happy today. Okay, we're back. So in our Doji GitHub action run, we should be seeing configure credentials one. This should show us the role that we were using. I guess if I click here, yeah, the role that we configured to use. And then in this other step that verified the AWS identity, we can see that we've successfully assumed that role and AWS thinks we are that role. So yeah, we managed to compromise the credentials for that. As I said before, we found this in several clients, and the credentials were like AWS admin. So the impact was insane.
No worries. You mentioned that if you have the wildcard in of the repo, like you got up there, anyone can access that. But I, as a amateur, I don't know you have that. So how can I discover that that is misconfigured from a black box perspective in order to abuse it?
Yeah, you just have to try. Basically, it's highly likely that you might find, for example, if you're pen testing a private company or something like that, you might have access to Terraform code in their repos. You might be able to see this. If not, you just have to either guess the name of the role that you're trying to abuse. There's several ways of knowing if a role exists or not in certain organizations. So if you know the ID, the organization ID, which is this part here of the account ID of a AWS account, you might be able to guess names just because names get repeated very often. Like maybe this was Terraform uh, apply or Terraformer or something. And in other cases, you can also do some tricks to make sure that role exists before you try anything, uh, using some other techniques that I think doesn't make sense to mention them here. You had a question? Uh, I can't tell you any information of any of my customers. I can say that I'm talking about experience before I was in Circle. Yeah, yeah, I can tell that. Yeah, before I worked at Circle, I worked with Carlos right here in Halborn, which is a cryptocurrency security company. So they do. Sorry? No, it's called Halborn. It's a Web3 security consultancy company. No, no, Halborn is the name of the company. So yeah, there we did do a lot of pen tests to other companies, and we also do some pen tests to companies in our own time. Cool. Any more questions? Should I go on? So that was going from CI/CD to cloud. Now we're going to look at the opposite perspective, and you might ask, like, if you're already in the cloud, why would you want to go like backwards into CI/CD? So what I found is that companies use the same CI/CD pipelines to deploy to multiple accounts. So maybe you have a very low privilege account that doesn't really like a development account or something, but they're using the same pipelines to push infrastructure changes to that account as they do to their production account. So going from that development account back into CI/CD can allow you to get credentials to then go to the production accounts. Um, Recently found this in a client, this same attack, critical. Really happy it happened because that engagement was going not so well. I wasn't finding much stuff, and then all of a sudden I got a critical. I was like, yes. Uh, they had a multi-tenancy platform, so they had different customers. All of them had access to a Terraform state file within their premises. So in their AWS account, each customer would get a different AWS account, and I was able to go from a customer account out into their system that ran Terraform, and then from there I had been able to go to other customers' account. So I bridged their multi-tenancy, like I went from one tenant to another, and that was like their biggest risk when we were having the preliminary talks on what was like the worst case scenario. They specifically mentioned if one customer is able to access another customer's stuff, then we're fried. We need to fix that, and that's exactly what I managed to do with this attack. So the attack, uh, first time I saw about it was in this blog post right here. This is not something I invented. A really clever guy. I had looked into this before, but I didn't think so outside of the box as this guy. So props to him. Uh, Terraform stores the current state in a file, JSON file. You can store that in an S3 bucket, which is just a file in a bucket in the cloud. If you have access to that file, first of all, you will be able to find secrets. Terraform, you can create databases, for example, and you can, by default, set a password for that database. You can generate a password during Terraform and set it as a password for the database. That password will get stored in Terraform state. So if you ever see Terraform state files, go have a peek. There's probably secrets in there, which might allow you to move to databases or maybe SSH because you compromise private keys, stuff like that. So that would be like pivoting within the same infrastructure, but we're trying to go backwards. So what we're going to do is editing that file. So we need write access to the Terraform state file, and we're going to add a new resource to the file. Whenever Terraform runs again, it's going to say, okay, the state says there is this resource. That resource is not in the code that you gave me, in the Terraform code that you gave me. There's a mismatch. I have to delete that resource. So it goes ahead and says, okay, what provider is this resource using to create and destroy? All of a sudden, that provider points to a provider that I created, which is malicious. And therefore, I control what gets run during Terraform destroys and Terraform applies of any resource that is associated with that provider. So I'm able to, whenever Terraform runs again, even in the plan or in the apply, it will automatically run my code, and I'll be able to get credentials and then move to other accounts or something like that. Is that good? You understood it? It's a bit of a complex thing because it goes backwards, and if you're not super familiar with Terraform and how it works, that Terraform state file might not mean a lot to you. I think I have a picture for it here. The attacker has write access to an S3 bucket in the AWS account, so this assumes like initial compromise, or in the case of the client I was talking about, a malicious client trying to attack another client. So they are able to insert in the Terraform state bucket a new resource that has a malicious provider, and that is not included in Terraform code in the repository here. So the next time that a developer goes ahead, pushes some code, they go through their usual flow, nothing alerts them because they don't see the Terraform state file. The pull request triggers the GitHub Actions. GitHub Actions will go ahead and grab the Terraform state, say, okay, I'm going to run Terraform apply. First does a Terraform init to get all the providers. That will include my malicious provider. So it already loads the code and it's ready to execute it. It says, okay, I need to delete this resource because it was here in the state and I don't know about it. I'm deleting it. And when that gets executed, my malicious code gets executed, and I have access to whatever they are using to assume roles into AWS or the other cloud providers. As I said, this doesn't need to be in the same account. Maybe you get access to credentials to other accounts. So a really interesting attack, and we can demo it, I think. Okay, so I'm going to use a Terraform provider that guys at Offensive Actions created, and it basically, this is the what we would write into the Terraform state file. So this is what a resource looks in Terraform state. It has like a type, a name, provider. That's where I specify the provider that I want to use, and then the instances is like the actual copies of the resources. And in this case, this resource just has two attributes, command and ID. So the command is whatever I'm going to run. So let me grab my, this might have broken. Like this. That should be good. So let's copy it. And now we paste it into the Terraform state. So this, oh, I don't have AWS CLI. I really not have AWS CLI. Let me log into AWS and see if I can do that. Let me unplug for a second. In the meantime, if anyone has any questions about this attack, feel free to ask. Yeah, not the first time I had to downgrade this piece of shit. Let's quickly try to downgrade that. I suspect it might not work. I think I used this one last time. Cross your fingers. Yay, fixed it. Okay, so I'm going to start a listener here. We have an ngrok runner, okay. Okay, the only piece I need is to download that Terraform state file and modify it. So let me cd back cd to number 5. Yes. Okay, so do I have this here? I'm just gonna download that file from the S3 bucket. Well, that file is not that big. Oh, I'm not in. I did not assume rolling here. Different one. Okay, I have that file. Should be in here. Okay. So now inside the resources, I'm just going to add a new resource, which is my malicious resource. I'll just make sure to copy it again. Okay. So everyone's still with me, right? We are copying a new resource into a Terraform state file. I'm gonna save this, and I'm just gonna push that resource back to the S3 bucket. S3, S3. So pushing it to the S3 bucket. Okay. The state file has been updated, and now we're just going to do a silly change here in order to retrigger this whenever Terraform runs again. So we're gonna make Terraform run again. Just adding main.tf. Okay, so I'm pushing a dumb change just to make Terraform execute again, but the payload is already in the bucket and all of that. We should be able to see this executing here. Okay, it's running. Okay, so if I go ahead and check the init, we should see it downloaded my malicious, here it is, installed offensive actions Terraform state RCE. And if I go further down, the plan has already started. So if I go here, I have a shell. And now we could run commands or print the env and grep for AWS. That would give us credentials to access AWS as the runner. So hopefully everyone managed to keep up with this demo. It's a bit more complex than the other ones. Any questions? Thanks. I'm really excited about this one. Yeah, I'm really glad I managed to fix AWS CLI. Okay, we're 47 minutes to go. Okay, so GitOps. What is GitOps? GitOps is a other way of doing CD. So previously we were looking at our pipelines were pushing code to the cloud. Here with GitOps, GitHub represents the desired state. So in GitHub we put whatever configuration we want, and then there is a system behind that is going to constantly be checking GitHub to see if we've made any changes to our desired state, or if the state in the actual system has changed and it's not the same anymore. And it will basically make sure that whatever is in the desired state in the repo is whatever is in production, essentially. So we're talking about Kubernetes. I love Kubernetes. So in Kubernetes, there's two ways of doing this kind of deploying. Really doesn't even have to be GitOps, but deploying stuff. You can do it directly manifests into the cluster, or you can do Helm charts. Helm charts are just a way of templating manifests, so they are more reusable, and you also have like version control. You're able to track what has changed from one version to another of a Helm chart. Uh, they're very useful. Most companies I've seen use them, and it's like almost a package manager for Kubernetes. Like you can find public Helm charts on the internet that allow you to install tools really easily. So a lot of companies are using them. And now we introduce Argo CD, which has a lovely logo. It's a declarative continuous deployment tool. That means it does what we were talking about. It will make sure that whatever you have in a GitHub repository is what you have in your Kubernetes cluster. So it syncs. Uses Git as the source of truth. It's able to support directly configuring manifests. using Helm charts or even using customized to make changes to Helm charts or manifests on the fly. So it's pretty flexible. And another interesting thing that I've also found in some companies is that it allows for multi-cluster support. So if the company has a lot of clusters, they might be using only one Argo CD to deploy to all those clusters. You compromise one Argo CD, you compromise all the clusters. Because normally the permissions that you give Argo CD are cluster admin. So it can create all kinds of secrets and like deployments in every single namespace. So normally there's no restrictions. Argo CD is admin permissions in Kubernetes. So multi-cluster can be juicy if you manage to compromise one cluster and get into Argo CD, you might be able to like compromise the entire company. There's also one other feature that will allow us to do another attack going back to GitHub instead of from GitHub to the cloud, from cloud to GitHub, which is that it allows you to, once it like templates the Helm charts, which is called hydrating manifests. Once it's that, it's able to push those back to GitHub, so they're back in GitHub and you can check them. That means that sometimes it can have push access to GitHub, which can also be dangerous if not configured correctly. So there's one big issue with GitOps. Whatever is in GitHub is what's in production. If you can push to GitHub, you can change production. So here is where I wanted to explain a bit about branch protection, which is a feature in most VCS companies like GitHub, GitLab, or whatever, that allows you to restrict who can push to main. And that means that there needs, normally you use it to have peer reviews. So there's like a 4i principle where at least two people need to check the changes in order to apply them to production. So you can use branch protection in order to do that. And basically, this is the only protection you really have. This and access control to your Git repositories is the only protection you have for someone doing like malicious deployments into your Kubernetes cluster if you're doing GitOps. At least in the CI/CD part. Maybe you have other protections inside your cluster, but that's it. So I wanted to show here a bypass. I'm not going to do the demo of the bypass, but this bypass is really cool. The first one, by default, before like until December 2023 or so, GitHub didn't have this setting that is here, and you probably cannot read because it's tiny. GitHub didn't have that setting which says allow GitHub Actions to create and approve pull requests. Does that sound good for anyone? So the idea of the attack is you can create a GitHub Actions inside. So you change the steps of GitHub Actions and you make it so GitHub Actions actually approves your PR. So since before there wasn't this setting that allowed you to make it so GitHub Actions could not approve pull requests, you could tell, okay, this is my pull request, and say GitHub Actions is going to approve it. I think it's December 2023, but I'm not 100% sure on that. So if your company was before that, if you created the organization before that, this setting will be disabled by default. If you create the organization after that, it will be enabled. So if you've been using GitHub for a long time, make sure to go and check that this setting is correct. This can be configured both at the organization and the repo level. So make sure it's correct in both places. You had a question? Okay. Okay, yeah. So as I mentioned, the way it works is you say, here's my pull request, and within the steps that run in that GitHub Actions, you make GitHub Actions do a curl request with a post in order to say, call the GitHub API and say, I'm approving this pull request. And automatically you will see a green check in your pull request and you're able to merge it. So it's a super fun bypass of branch protection. Is that what you were thinking I was going to say? Yeah, it's actually a curl request to the GitHub API. Another example of bypassing branch protection is PR hijacking. This means you find someone else. This can also be stopped with some settings, but essentially the attack is I find someone else that raised a PR the PR already got approved, or I can approve it if I have the correct access. So once it has a check, I'm able to push my malicious code to that PR and merge it. So the way to stop this is by activating some of these settings, which say this makes stale pull requests approval when new commits are pushed. So if someone pushes a new commit, you will need to approve again. I actually don't know the defaults, but I'm pretty sure by default that's not checked. So by default, you are able to push commits even if someone else has already approved, and the approval will remain. You don't have to approve it again. And the other one says require approval for the most recent reviewable push, which is basically more or less the same. Okay, so that could be used in conjunction with GitOps in order to bypass branch protection and push directly to main, and therefore gain access to Kubernetes clusters if you're using Argo CD. Or we'll see another example that does the same thing but directly into AWS. 39 minutes. Let me see. I think we can do this one, skip the next one, and do the last one. Okay, so let me walk you through this. We're going to skip the part that does the branch protection bypass, because as I said, in private repos, if you're not paying, GitHub doesn't allow you to do branch protection. Doesn't make a lot of sense to bypass it if it's not even working. Like, you can create the rules, they just don't apply. So I don't need to bypass it. It's already bypassed by GitHub. So the attacker makes a pull request that changes well, you merge it into main. We're going to push directly to main. Once the change has been in main, Argo CD will say, okay, there's new changes, I need to sync. And it will go ahead and install whatever you want to install. In this case, I install a new bad pod, which is just a pod that mounts the entire file system of the Kubernetes cluster. And from there, we're going to escalate privileges to Kubernetes admin, because to this bad pod, I'm going to assign a service account that is Kubernetes admin. So quick, easy demo on how to escalate privileges in Kubernetes. Let's see. GitHub to Kubernetes, yes, this one. Let me actually show you what we're running. So for this demo, I've set up a cluster with a Argo CD running on it. Okay. So currently, this is the application that is running. We could even see this application in GitHub. Let me show you that. So this here. Okay, so we have a Helm chart for engines, and it's basically just it deploys a couple of things to run an engine server. It's actually this server here if it loads. If it doesn't load, I don't care. So essentially, it's deploying this infrastructure here. Just a couple of pods running engines and some other services and stuff to be able to access it from the web, which you can see here. This is the actual like web deployment I did. All of that is in this GitHub repository. And if I go to my README and I see the steps for this, I'm going to be creating a service account and a cluster role binding, which is going to attach the group cluster admins to that service account. And then I'm going to create a pod that uses that service account. And it is going to send me a reverse shell. So I need to update this to my new ngrok thing. Okay, so let's put this into the Helm charts and trigger that pipeline. So just copying this. Let's put it pretty much anywhere here. Deployments sounds good. So all the way at the bottom, I'm just going to do this. And I'm also going to add the pod. Okay, add this here. Double check I did set ngrok correctly. Yes. Okay, so I have a listener running. No, I need to run the listener. Okay, we have a listener. And now if I do a git push on this, let's make this bigger. I did do it from the CLI. Can't see anything. Okay, so if I do a git, let's do status. Did I save? I didn't save. So git status, git add, git commit, and git push. Okay, that's pushing. Argo CD should, in a couple of seconds, realize that there's new code in our repository and start syncing it. And we should get a reverse shell with Kubernetes admin. I think I can actually manually sync it. Argo CD by default syncs every 3 minutes. So I'm just gonna try to make it sync. Okay, created our service account, which is admin, created our pod. We go into the pod specs. It might take too long to do it, but essentially it's going to say desired manifest. Give me something we can read. There should be in here a place where it says that this pod is using the service account. And once that starts, we get a shell. And here is our shell. Oh, I killed it. Anyways, that's our shell. That pod will have the host file system mounted. So we have access to some tooling like CryoCTL, which allows us to interact with containers in that cluster. And we have that service account that is Kubernetes admin. So we would be able to do whatever we want in this cluster. Okay, so moving on. Yeah, I'm trying to go fast. Half an hour left. I want to show a couple more demos. So this would be the other way around. Yes, from I've compromised a cluster. Maybe I got in through a web application that had an RCE. Maybe I got in through like some other permissions or something. Uh, if I'm able to read a secret that is located in the Argo CD workspace, I might be able, well, I will be able to compromise GitHub credentials. Those GitHub credentials could possibly be very privileged. I found companies using GitHub administrator credentials, like GitHub owner of the entire organization credentials here, which meant that I was able to go from compromising one cluster to compromising their entire GitHub, which then compromised their entire company. So I don't think it's worth doing this one, but I will show you the steps because it's a bit weird. So here, if anyone is really interested in looking at the details of any of this, find me around the conference. I'll give you a personal demo. I love talking about this nerdy stuff. So uh, what we're doing here is, so this assumes that we have access to a cluster. We can get secrets in the Argo CD namespace. We find a secret that is called repo and then a random value. That means it's a token from a GitHub repository. We leak that secret, and that gives us a GitHub app, a GitHub app ID, a GitHub installation ID, and a GitHub app private key. With those three pieces of data, we're able to authenticate against GitHub. Even easier if you use the recommended, if you follow the Argo CD docs, you will be using a GitHub personal access token, a PAT, personal access token. That's only one thing. You don't need to do any other interaction. You pass that to the GitHub API, and GitHub API just says, okay, that's good. So with this, you actually have to go through like a little flow, a little dance to get some credentials that you can actually use in the API. So I'll show you what that looks like. I leaked the secrets. Okay. And then you need a little Python script that generates a JWT token, which is basically you're putting these claims into the token, and then you're signing with the private key that the GitHub action has. This is all well documented online. This was generated by ChatGPT. I didn't even use it. I didn't even do it. So uh, you will need some dependencies. You run it, and you get a token. With that token, you're able to query this API from GitHub against tokens, and that will give you a token that looks very similar to a PAT, and you can use with any other GitHub API, which is what we are doing here. And the fun thing about this demo was that I was actually that GitHub app that I created had permissions to invite users to the organization. So with this API call here, I was creating a new invitation to another email ad control with the role admin. So I was essentially inviting someone as admin to the organization, therefore escalating privileges in GitHub to admin. Okay. Any questions? I see some people are still with me, which I'm really glad. Some people are actually understanding something. Okay. Crossplane. Crossplane is a cool tool, also a really cool logo. This tool is used to create infrastructure in your cloud provider as a Kubernetes resource. So you use a custom resource definition, a CRD, in Kubernetes to define things like S3 buckets, IAM roles, RDS databases. I've seen startups that use this a lot because it means that their infrastructure and their all the infrastructure stuff inside Kubernetes and outside Kubernetes for a certain application is within their Helm charts. So they're able to like template it to use in different environments. It's helpful for that. I find it really risky because essentially the place that you're running your workloads, Kubernetes, has access to create anything in AWS. So a compromise of one of your workloads, which could be like an RCE in one of your web apps or something like that, would be like catastrophic. It potentially would be like AWS admin. So if you combine Argo CD with Crossplane, you have GitOps for AWS, basically. Whatever is in your desired state in AWS, you can sync it directly to AWS. Whatever is in your desired state in GitHub, you can sync it to AWS. Okay, so this would be an attack. I also don't think it's worth doing it. No, it's not worth doing it. It's essentially the same thing I was talking about in the Argo CD one, but instead of creating a pod that has a malicious service account or something like that, we trick Crossplane into creating an IAM user that is admin or something like that, and we get the credentials. So, yeah, interesting. I thought it was worth mentioning. If we had more time, I would show you the demo, but yeah, it's not too interesting. I can show you what it looks like to actually create those resources. So these are still Kubernetes manifests, but as you can see here, they have really weird API versions. Normally, this would be like either app or version 1. That's like Kubernetes native stuff. When you are using CRDs, you will have other strings there. They point to other like providers of objects in Kubernetes. So this one is of the IAM AWS provider, and it's a user. So it's creating a user, the name, the namespace, because this is a Kubernetes resource, so it's a namespace. It's a namespace inside Kubernetes for the object, but then the actual AWS resource doesn't have a namespace that gets created in AWS. Then we're creating some access keys for that user in order to access it, and we're attaching a policy to the user for administrator access. So yeah, that's pretty much it. If you were to deploy this using the same methodology we did before with Argo CD, you would be able to get a credential for AWS admin, for example. This depends on what permissions you give your cross-plane provider in order to create new resources. But normally, as I said, people give it admin. So, yep. Any questions on crossplane or this attack? No? Okay. I've seen it used in one pretty big startup where I used to work for a long time, and they had this exact issue, and we had to do some mitigations around it to make sure that okay, you can create IAM roles, but not with more permissions than this and all of that. But I think it's getting quite popular. It's very opinionated, in my opinion. Like, yeah, yeah, exactly. So if you like how it works and that workflow works for you, makes sense to use it. I would much rather prefer using Terraform and keeping my infrastructure as code separate from my workloads as much as possible. Yeah, but I see why they use it. It's convenient for creating a Helm chart and making developers uh, create their own infrastructure instead of the TechOps team having to create infrastructure for them. Cool. Moving on to GitHub self-hosted, GitHub Action self-hosted runners. So the runners that we were using before for the other demos, they are GitHub hosted runners. So those run in GitHub servers. We just give them the instructions and they spin up a VM for us, run the pipeline, and give us the results back. That might not work for a lot of companies because of regulations and stuff like that. You might need to, for example, there's a regulation that says that everything that touches production needs to be self-hosted, like it needs to come from your premises, especially like in financial companies and stuff like that. So that means I cannot use GitHub Actions with the GitHub runners because that belongs to GitHub. If I'm running pipelines, I need to run those pipelines on my premise. So a lot of people are using GitHub self-hosted runners, which means I run the runner integrated with GitHub Actions, and GitHub Actions sends me the steps. I execute them. I send the results back to GitHub. The workflow is more or less seamless for the person using it. You're able to control. Well, let me actually. There's a slide about it. You're able to control things like what kind of performance the machine has. Maybe you have workloads that need GPUs, and GitHub doesn't provide that. Maybe you need to build something that is huge, and the default GitHub action runners they run out of memory, and you need to provide more memory. So for those kind of things, they're also useful. You can like make it a huge VM with tons of GPUs to perform your pipelines. It's also a custom environment. In GitHub Actions, you can provide Docker images to run your actions in, but with this, you can like install anything in that system that you want. You can install monitoring, you can install pretty much anything. It also has private network access. If I deploy in my own premise, I control what networks it can talk to. Maybe I have some internal systems I want to deliver some packages to, like, I don't know, maybe ECR in AWS, a container registry in AWS, and I only want it to be accessible from my own VPC. So in that case, I could use this, and it has private network access. And also for privacy concerns, as I was mentioning, there's regulations that will just not be okay with you running things in GitHub runners. So there's this neat tool called Arc, which is the Kubernetes Action Runner Controller. And what it allows you to do is spin up dynamically runners in Kubernetes. And whenever there's a need for a runner in your GitHub Actions, it will say, okay, we need a runner. We need a runner of this kind of runners. You can specify different runner sets. And it says, okay, I need a runner of type A. And then it will spin up a runner for you in Kubernetes, use it, and kill it just after it gets used. So for companies that are using Kubernetes heavily, this is the way to go to run GitHub. I've seen this a lot. And yeah, that's pretty much it. Very cost efficient because when you're not using them, the runners are not running. Uh, Also ephemeral, you kill the pods, and that's pretty much it for the runners. Here's a diagram on how they work. It's pretty complex because it has a lot of back and forth. But essentially, the idea is I define my steps in GitHub. I configure my pipeline to run on a self-hosted runner. That will make a webhook to a Kubernetes controller. Kubernetes controller will say, okay, we need to run a runner. What kind of runner is it? The runner listener here, this pod here, will say, okay, we need a runner of my type. I'm going to spin up that runner, spins up the runner. The runner there collects the steps from GitHub, executes them. It does whatever it needs to do in the pipeline, and then reports back with the results to GitHub, essentially. So that is cool, but now we're running GitHub Actions inside Kubernetes, which poses some complications. Because, for example, a lot of people use GitHub Actions to build Docker images, well, container images. I say Docker, but container images. The issue is you're running inside a container. You can't really build a container inside a container. You need to do some trickery in order to do that. So this is what I wanted to introduce, Docker in Docker, which is a technique to run a container inside another container, which is not really 100% true because both the containers are running in the same kernel, which is the host's kernel. There's no other like isolation or security boundary. So there's two ways of doing Docker in Docker. Full DND, which is like the abbreviation of Docker in Docker, which means that the first container is actually running a Docker daemon. Docker daemon is the tool in charge of like managing the container and making sure that it essentially makes Linux run the container with the Linux, like the namespaces, the C groups, all of that makes it work so it runs the container. This is cheap by using the Docker :DND image, and it is, I would say, more secure than the second option, but it's still not secure. There's still risk with it, and we will do a demo on it. Yes, we will do a demo on it. The other option is to bind the Docker socket directly into the container. So in, well, containers in general, specifically in Kubernetes 2, you can do volumes from the host into the pods. So I can say this pod has access to these directories. And if you expose the Docker socket and you have Docker installed in that container, you will be able to run Docker commands on the host. In order to do that, you will be able to create privileged pods, for example, and therefore you could escape and become root in the node instead of in the container. But that also happens when you're using full DND, because it's a bit more difficult. We're gonna do it in a demo because you don't have direct access to the Docker socket. The Docker socket that you interact with when you're inside DND is the Docker socket from the daemon in the first container. So you think you're escaping your container, but you're actually in another container. It's like the Russian dolls. You're in the container inside, you escape to the next one, but you're still in a container. And then you figure out how to escape that container. So yeah, we will be looking into a demo of that, this one here, which involves like 2 container escapes in order to escape to the host. So the idea here is we have an attacker, they push malicious code, opens a pull request that triggers GitHub Actions. This GitHub Actions is running in a self-hosted runner. The hosted runner is using the DND image, so it has access to run Kubernetes Docker commands. And therefore, we will have a runner and a DND sidecar. A sidecar is just when you have multiple containers in the same pod and they communicate between them to do different tasks. In this case, so that this runner doesn't have access to Docker daemon, they put it in here in another separate container. There's communication lines between them using the Docker socket, and that's a privileged container. So not much of a security increase, but it's like it makes it look nicer. Essentially, what we're going to do is from the runner execute a Docker command to create a new container. That container is going to be privileged, and we're going to mount the host file system. But remember, this container is inside this container. So we're going to be privileged inside this container, and we're going to have the host file system of this container mounted. So we will need to escape that first container. We will land in the Docker container, and then from there, since it's privileged, we will be able to escalate to the node that is running these pods. And then from there, once you are in a node in Kubernetes, most likely you're going to be Kubernetes admin because there's going to be some container inside that node that has permissions in the cluster. So if I'm able to interact with all the containers in that node, highly likely I will be able to obtain some credentials for Kubernetes that are privileged. Everyone with me? Okay, let's do this last demo. This one is cool. 15 minutes. Yeah, probably will need to skim really fast through the supply chain part, but I think this demo is cooler than supply chain. Okay, so we again have a GitHub repository. We're going to do a GitHub action in this repository that triggers in main. You can see here the self-hosted runner that I'm going to be running in. It's called the indeed run set. So it's using Docker in Docker. And this is the command that we're going to run. We're going to run docker run, adding all capabilities, which is a Linux protection thing. So we're disabling that. We're getting ourselves host PID, which means we run as the host process ID. Remember, that would be the host PID of the DND container, not the host itself. So second layer of the Russian dolls. We're running privileged. We're mounting the Docker socket. We're mounting the entire Docker, the entire host file system into /host. And then we're sending a reverse shell using netcat. So I need to update my nrock address. Okay, so now I can go ahead and make sure I have a listener. I want to make sure I have internet. Okay, we're looking good. So now I copy my pipeline steps. And I'm going to paste them into this pipeline. I already had them here. Okay, so now when we push this, we will get a reverse shell inside a container inside a container. Oh, it already runs. Oh, because we didn't kill this. We're getting a reverse shell from the previous demo. I need to kill this pod. Ooh, actually, I need to. I need to undo this commit that we did here, or else it won't work. Now I need to sync it. Why did this die? Okay. Sync. Okay. I'm destroying the things from the previous demo so we don't get reverse shell all the time. Hopefully no more reverse shells for now. Later we will want a reverse shell, please. Okay, so I go to demo number 9. Did I already commit this? So we're in demo 9, test.yaml. This is saved but not committed. We got another reverse shell. That pod should be dead. It's not dead. Terminating. Terminate faster. Force delete. It's not not deleting fast enough. Looks like it's not giving us more reversals. Let's hope it stays that way. I need to do a GitHub status. Okay, need to GitHub add, git add, git commit, git push. Okay, so now we're triggering a new pipeline in our other repository. That pipeline should be executing in our GitHub self-hosted runner with Docker in Docker. And we should get a reversal inside a Docker inside a Docker. This one here. Okay, this is running. Let's check it. Okay, yeah, it looks like it's installing Netcat, which I told it to do. And we got a reversal. If I click on this side, we have a reversal. Let's do some steps to quickly privilege escalating here and then have 9 minutes, okay? First of all, I'm going to chroot. Anyone know what chrooting is? I'm changing the root of my file system to the host directory. That's where we mounted the entire file system. So now if I do ls, I should see the file system of the Docker in Docker container. So I've moved into the second container in our container Russian doll. So I'm going to make a directory in this container. This is a really normal privilege escalation technique, nothing crazy, which consists of we're going to, since currently we are in the Docker in Docker container, which is privileged. Normally, privileged containers have access to the dev directory here, and this that we see here will be the actual drive, like the actual hard drive of the node. And therefore, if we can mount the hard drive of the node, we have access to the file system of the node, and we will be able to like escape from this privileged container. Since we were in another container, we've escaped the first container into the privileged container, and now escaping the second container, the DND container, into the host. So I'm running mount just so you can see the output of that. Or maybe not. Let me try this. I think that root didn't work. Let me, this is a cool way of knowing which container I'm still in. Okay, I'm in the DND container. This should work, I think. Maybe it did work and I'm just not. Let me do an ls of mount test. Oh yeah, it did work. Okay, so now we have the entire file system of the node mounted into our container. We're going to chroot into that directory. So currently we are root and we have access to the host's file system, the node's file system. The thing is, we're still restricted by some things, like our process is still not at the host level. We're still within a container. So if I were to run a PS, for example, I don't see any other processes. I just would see mine. So what we're going to do is create a cron job in order to send us another reverse shell in 1 minute that will be executed by the actual node. We're just going to edit the cron tab files to execute a cron job in 1 minute, and that will send us another reverse shell. And that way we escape the container entirely. So just copy this. We're almost done. Okay. Okay. That created a file. I'm going to echo my reverse shell into that file. Now I'm going to make cron have that configuration. We're going to double check that that actually happened. And as we can see, we added our own reverse shell. And now I can remove that file. I'll remove it, but doesn't really matter. And now if I exit like 8,000 times, because we're inside a container, inside a chroot, inside a container, inside a chroot. Okay, now I can set another listener, and in about a minute, we should get a full reverse shell from that node. While that goes, I'm going to continue. We can check if that worked later or not. That's like cliffhanger for you. Supply chain attacks in 4 minutes. So here, instead of attacking the actual software that we run, we're attacking things that we trust indirectly. First one I wanted to talk about is dependency confusion. I found a cool example of this. Well, this blog post at the bottom is amazing. If you haven't read it, I think this was 2023. It was voted vulnerability of the year by OWASP. So definitely check out that blog post about dependency confusion. I found the same vulnerability in a AWS service called Code Artifact, and it allowed you to do this attack, which essentially is if you are using internal packages that are private and you have not registered those packages in public repositories, and an attacker is able to push to that public repository a higher version of the package, then some of your systems might default to the higher version and install their own the attacker version, which is a higher version, and therefore the attacker obtains command execution normally in your CI/CD pipelines or your developer machines. Potentially, if they do it quietly, they could even reach production without you noticing, and that would be bad. But yeah, the attacks I've seen around this are all targeting CI/CD. So the other one is using compromised GitHub actions. This is the example I was talking about, TJ actions before. Essentially, an attacker compromises a GitHub action that you use whenever your pipeline executes that GitHub action, executes malicious code, therefore getting the attacker access to your GitHub actions. As I mentioned before, the TJ Actions one, it targeted Coinbase. I think this was like second week of March, so very recent. And they managed to execute code inside Codebase in the repository, but Codebase had some defenses in place to block traffic outgoing from their pipelines. So they were able to block the attack, which was pretty impressive that they were able to do that. Other than that, when they got caught, the attacker decided that exfiltrating secrets of 23,000 repositories was interesting. So they went ahead and do that. And this is just so you get an idea of how crazy this attack was. The attacker compromised one repository. From that repository, they were able to extract a maintainer's path, a personal access token. So they were able to impersonate that maintainer in GitHub. Using that access, they compromised another repository. And with that repository, they got another pair of credentials for GitHub. They compromised a third repository. In that repository, they changed one of the tags. Tagging in GitHub means that you make like a reference to a specific commit. So they changed one of the tags to make sure that anyone that used this GitHub action would pull a malicious version. That GitHub action is a dependency of this other GitHub action. And this GitHub action is a dependency of this other GitHub action, which is the TJ actions change file, which tons of companies use. Like I know at least 3 companies that use it that I've worked in. So there's a lot more. When they manage to access that repository and get a malicious action with a specific tag, first they were quiet. I'm only going to override version 39 because they knew that Coinbase in this repository, which is public, were using that specific version. So they said, okay, I'm going to be quiet. My attack is only going to target Coinbase. So they had a check. If it's Coinbase, send the credentials to the attacker. Coinbase executed this. The credentials were getting sent to the attacker, but they blocked it. Great on their part. When that happened, the attacker decided, okay, we need to go fast. They've caught us. So they did replace every single tag in that repository for that action, and everyone's credentials were getting printed to the workflow logs. So now they would be able to go into the logs in every single repository of those and just check the credentials. So yeah, the attack was very crazy, and the detection capabilities by Coinbase pretty impressive. And that's it for today. If you're interested in any of the courses from Hacktricks Training, make sure to use the code HackSpaceCon 2025. We have an AWS certification, an Azure certification, and a GCP certification. Hopefully next year, Kubernetes certification coming. So if you're interested, make sure to check us out. And I guess we need to find out if we got a rare shell. We got a rare shell. Let's check the host name. And we are in the EC2 instance, which means we managed to escalate to the node. We could even do like PS, not less. This shows us that we have access to every single container running in this node, which means we could move to them and exfiltrate credentials for other clouds or maybe Kubernetes credentials, anything like that. So that's it. Thanks for coming, and I hope you learned something.